Okay, kids, I'm going to go through these assignments with you just real quickly so that you can look at them. If you'll go to the class webpage and you call up or study guide, not the study guide, but we're going to look at the review problems from Chapter 2. I want to go over those with you, do a little bit of explaining on them. So which of the following is not a physical change? So physical chemical changes, remember, if you change the appearance only, or the size, shape, or anything like that, it's physical. Chemical, you have to change the composition. So if you dissolve sugar in water, it's still sugar, it's still water. They're just combined to make a solution. So that's a physical change. Burning gasoline, gasoline does not come out of the tailpipe. You have to keep buying gasoline, so it must turn into something else. So that's chemical. Well, let's just check our other answers. Evaporating seawater, water goes up into the sky, the salt is left behind. You haven't changed them, you just got the salt that was dissolved back out. If you slice a piece of bread, it's still bread. It is just a smaller piece of bread, and that's only considered physical. It'd be hard to put the bread back together, but still that's only considered physical, which is not a property of a gas. Remember, gases have no definite shape or no definite property, or excuse me, volume. So has a definite shape is not a property of a gas. These other three would be okay, but I just want to, so we don't have to spend tons of time on this, I'm just going to go on. Which is not a physical property of sucrose. So anything that's chemical here would be not physical, obviously. So decomposing when heated, because it turns into something else. You guys did that lab, and you got the black stuff, and that black stuff is definitely not sugar anymore. Actually, it's carbon, it's charcoal. Which of the following is a different physical state than the others? Well, salt at room temperature is a solid. Sugar at room temperature is a solid. Flour at room temperature is a solid. Water is a liquid at room temperature. So I'd pick water there. Gases, do they have a definite shape? They do not, do they? Do they have a definite volume? No. Are they easily compressed? Yes, you can put them into cylinders and whatever. No definite shape, and you can't compress it. You know what they're heading for here. Liquid, this is going to be solid. So they do have a definite shape and a definite volume. Liquids do have a definite volume, and you can't compress either one of these states. Which you have to look at a table in the book, so we're going to skip over that, the 6 and 7. And let's classify the following properties as intensive or extensive. And remember, intensive means the property doesn't change no matter how much matter you have. Extensive is it changes if you have more matter. So color is intensive. Volume, extensive. Mass, extensive. More you have, more mass. More you have, more volume. More you have, color still stays the same. Boiling point, tricky one. Doesn't matter how much water you have, it still boils at the same temperature. So that would be intensive. All right, moving right along. How might you separate a mixture of water and milk? Or excuse me, water and salt. Well, I'd probably evaporate them. Now, if you have to keep the water, then I would probably distill it, because then I get the water back and the salt will remain behind. Homogeneous mixture looks like one thing. We also call it a solution. Which of the following mixtures are homogeneous? Gasoline. I don't want to see parts in my gasoline, so that would definitely be homogeneous. Chunky peanut butter. I can see the peanuts. I can see the peanut butter. I'd call that heterogeneous. Oil and vinegar salad dressing. Oil and vinegar salad dressing, there's two different layers of oil and vinegar in it, so that's going to definitely be heterogeneous. Which of the following are substances? Remember, substances are pure. Elements are compounds. Ethanol is a compound, so it's a substance. Motor oil is actually a mixture. That's a tough question. Vinegar is water and the chemical that makes up vinegar, so it's a mixture. Neon's an element, so that's a pure substance. What elements are in ammonia? Nitrogen and hydrogen. I'm going to skip all these parts because we are not going to, or no, I'm not. I'm going to skip the more questions about symbols because we're not going through the symbol thing. So which one's an element, compound, or a mixture? Salt. Salt is a compound. NaCl. These are, a lot of these are from your lab. Water is a compound. Iron is a element. Stainless steel is a mixture. Write the chemical symbol for each of the following elements. Tin. We don't have to do this part. Let's keep going. A liquid is allowed to evaporate and leaves no residue. Can you determine whether it's an element, a compound, or a mixture? My answer would be no, because if it was an element, there are a couple liquid elements. If the element evaporates, and nothing should be left behind. If it's a compound, if you have pure alcohol and you just let it evaporate, nothing will be left behind. And what if it's a mixture of alcohol and water? Well, the alcohol and the water would both evaporate, so nothing would be left behind. So you could not tell whether it's an element, a compound, or a mixture. That would not be a good way to tell. Which of the following is not an element? So all you got to do is look on the periodic table to see if the names of those elements are there. Copper, sulfur, and helium are all there. Sucrose is a compound, that's sugar. Which is a chemical change? Gasoline boiling. This is the one everybody misses. Changes of state are physical changes. You're just changing from liquid gasoline to gaseous gasoline. Oxygen is added to gasoline. Still just a mixture. Gasoline burns. Now that's chemical. You don't get it back when you get finished. Pour the gasoline into the tank. That's obviously physical. Classify each of the following as physical or chemical change. A puddle's dried up by the sun. It's just water. It was a liquid, now it's a gas. Dark cloth is faded by the sunlight. Color change, we said color changes are usually chemical. Bread is toasted. Color change, taste different, chemical change. Soap is mixed with water. That's physical change. If you evaporate the water back off, you get the soap back. Now there you go. If you catch all the water in your bathtub and go evaporate it, you never have to buy soap again. It'd be dirty soap, but it'd be kind of awesome, wouldn't it? Carbon dioxide plus water yields carbonic acid. Products are the things you make, so that's going to be the carbonic acid. And the reactants, carbon dioxide and water. Now, law of conservation of matter. That's the answer to number 6. If I have 44 grams of carbon dioxide and 18 grams of water, how much carbonic acid can I form? The reactants have to equal the products. So 44 plus 18 is what? 44 plus 18 is, let's see, what would that be? A pencil, like usual, is not working. Let's try it again. So 44 plus 18 is 62 grams. So 44 plus 18 equals 62 grams. Now in an engine, you have octane and oxygen. It makes carbon dioxide and water. So we have 22.8 grams of octane and 80 grams of oxygen. Makes 70. So we made 70.4 grams of CO2. Now they also tell you that you make water. So this problem is a tiny bit harder. We have to add these two up. So we get 80 and 22.8 is 102.8 grams. And over here we made 70.4 grams. Plus we don't know how much of this. So 102.8 minus 70.4. Looks like that's going to be about 32.4 grams of water that you would make. So that's that worksheet. There's really not much else to explain to you on the others. Just make sure you don't screw these things up because that's going to be 90% of the test. So what I'm going to do real quickly, I'm just going to go look at that one. I know you have the answers down there for the, where is that? Down here on the test date. There's a PDF of the review packet, and there's a practice for the test with answers. We'll look at that one in a minute. We'll look at this PDF. The answers are down there. So really, just remember that in a solid, liquid, and gas, if you draw 8 particles of each one, here you want to show them all close together. I'm just going to go down and look at the pictures in the first one, and then you want to draw them kind of sitting in the container at the bottom, draw them all over the paper, and then show them electrically charged up here in the plasma. If we go back up, just going through these a little bit, neon is an element, orange juice is a mixture. Depends on if there's pulp or not. If it's not, now typically you know my rule. If you can't see through the liquid, it's probably heterogeneous. I can't see through orange juice. Orange Kool-Aid I can see through. I'm going to tell you, even if you can't see the pulp, orange juice is still heterogeneous. So if you're looking at a liquid and you can't see through it, 99% of the time it's going to be heterogeneous. If you can see through it, it's going to be a solution. Clean air is going to be a solution. It's a mixture of gases. Carbon dioxide, CO2, is a compound. What's the difference between a mixture and a compound? Physically mixed, chemically mixed. More than one element chemically mixed, more than one substance physically mixed. So they're both mixed. That's how they're alike. How are they different? Physically, chemically mixed. How are homogeneous and heterogeneous different? Homogeneous looks like one thing. Heterogeneous, I can see the parts. Chex Party Mix, Kool-Aid. Several ways to separate mixtures: distillation, chromatography, filtration. And the fourth one we listed was magnetism, and the fifth one was just pick them apart. How could you get apart a mixture of sand and sugar? I tell you what I'd do. I'd put both of them in water. I'd filter the sand out, and then I'd evaporate the water off and get the sugar back. Law of conservation of mass: cannot create or destroy matter. We just went through 2 problems with that. Can only change its form. Gas and a vapor. Gas, they're both gases, but the vapor is supposed to be a liquid at that temperature, whatever it might be. Flexible, chemical or physical? Physical. Combustibles, chemical. Boils at 20. That's the tricky one. Boiling is a physical change. Reactivity is always chemical, so that's chemical change, or chemical property. Which of these are extensive or intensive? Extensive, mass, volume. Intensive, melting point density. Grapes fermenting turns into alcohol, so that's chemical. Copper melts, physical. Recycling aluminum, all they do is change the shape, so it's physical. Gasoline exploding, chemical. Water evaporating, physical. Eggs cooking, eggs change. They're not that clear, colorless fluid. It turns into a white substance you can't see through. So there's a color change when you cook them. And the bright yellow turns to a dull yellow. So the color change should give it to you. Rusting iron, it changes colors. Chemical again. Wood burning, make gases. That's a good evidence there. Mixing cake batter, it's just physical. When you bake a cake, everything takes on a different appearance and tastes totally different, so that's going to be chemical. All right, we have one more, and that is the review guide, and I think I gave the directions to that. I did not, apparently. So let's go back to that for just a minute, if we can. Practice for the test with the answers. Chapter 2 review. There it is. Oh, that's that same one. I'm sorry. And it has the answers with it. So look over the study guide. Let's just look at that real quickly, just to make sure that I didn't leave off anything. And we should be good here if you want to do that. If not, you can cancel at any time. Let's see. Study guide. We've been all over physical chemical changes and properties. Properties in a change. Property is something that describes something, like an adjective. A change is you actually see it happen. States of matter, we went through some questions of that. Substance versus mixture, pure versus not